Okay, the difference quotient. So we are going to replace the x with x plus h. Okay, that's squared. 3, we're going to replace the x with x plus h. Then we're going to subtract the original 2x squared plus 3x. That is what that is saying right there. And it's all over h. I'll leave that for later. So, x plus h times x plus h. Don't just square the x and square the h. X plus h times x plus h will give me x squared plus 2hx plus h squared. Again, distributive law here. 3 times x is 3x. 3 times h is 3h. Still subtracting the original f of x. Okay. Right, more distributive law. 2x squared plus 4hx plus 2h squared. Still the 3x, still the 3h. Still me subtracting all of this, okay, the original function. Right, now then, this is what's going to happen. The 2x squared minus the 2x squared over here. The 3x minus the 3x over here, okay? All that's left, if you'll notice, are terms with an h in them. That's what happens. They've all got h's. Because if I factor out an h, here we go, for x plus 2h plus 3, okay, out of that one, and that one. Remember now, it's all over h. They'll cancel, and that will be your answer. 4x plus 2h plus 3. Okay, next one. Okay, so what's g of negative 1? This is the g equation. I'm going to put negative 1 where x is. That is 2 plus 3. That is the answer. Okay, the square root of 5. Okay, let's look at this one. This means, first of all, do g of negative 2, and then you're going to put it into the h. So again, square root of 2 minus 3, x is negative 2. So that equals the square root of 2 plus 6, that is the square root of 8, okay? 2 plus 6. Now, I can also write that as 2.828, but for now, that's okay. Although if I do have to put this or this into h, all right, which is up here, I've got to do this. 4 minus the square root of 8, or 2.828. That's me putting this into the h equation, and you just put that into your calculator, okay? Right, next one. The domains of these. Okay, the domain of g of x. Remember, you cannot square root negatives. In other words, whatever's inside the radical must be greater than or equal to 0. Take away 2 from both sides. There we go. Divide both sides by negative 3. X. Now remember, that will change the direction of the inequality because I divided by a negative. That's still positive 2/3. And there's your answer. In interval notation, that is negative infinity to 2/3. Okay? Finally, the one at the bottom here. The domain of h of x. Remember, you cannot divide by 0. Okay, this cannot be 0. What can you see? X cannot be 4. Okay, from that you can't have 4. So negative infinity to 4, and then 4 to infinity in interval notation. And the last one in this particular video. Write a rational. Now remember, horizontal asymptotes, they come from looking at the order of both numerator and denominator. If you have something that's bigger on the denominator, it's always y equals 0. For this one, when they are the same order, 2x squared over 1x squared, it's just 2 divided by 1, y equals 2. Okay, it's just look at that leading there. Okay. Right, that's the horizontal asymptote done. I'm going to look at the the vertical asymptotes. Okay, that comes from the denominator. Again, x squared minus 1. Remember, with domains can't be 0, so these are the vertical asymptotes. So x is going to be equal to plus and minus 1. Okay, so the vertical asymptotes is x equals negative 1 and x equals positive 1. Right, there is no oblique asymptote. The domain, well, the domain of this is just negative infinity to negative 1, and then negative 1 to positive 1, and then 1 to infinity. We've basically already got it here because we answered the asymptotes, okay? Right, next one. X-intercepts. Now we look at the numerator, okay? So remember, denominator for vertical asymptotes, numerator for x-intercepts. We have to factor it, like we factor the denominator. Right, this is going to give me, let's have a think about this. That's going to be plus 3 and negative 1. So my zeros, my x-intercepts are positive 1/2 and looks like negative 3. Okay? And of course, looking for the y-intercept, we set all the x's equal to 0. If all the x's are equal to 0, I just have negative 3 over negative 1, which is positive 3. So that's all the information I need to graph, which I'll do over here. So, vertical asymptotes at 1 and negative 1. Horizontal asymptote at 2. Okay, so y equals 2, x equals negative 1, x equals positive 1. Oh, what do we have? A y-intercept of 3, x-intercepts of 1/2, and negative 3. So this is probably what it's going to look like. It's going to go close to that asymptote, cross through the x-intercept, and close to that asymptote. There's probably going to be one over here. You can always check on your graphing calculator. Okay, all I have to do is plot some more points, like let's say plot x equals 2, see what I get, plot x equals 3, see what I get, put them back into the equation. Now what I've got left is, looks like I have to hit that y-intercept and the x-intercept. Now remember, you can't cross vertical asymptotes. It's okay to cross a horizontal, and this looks like the only thing I can do then. There we go. So that must be the graph of that rational function. And you can always check by looking on Desmos or your graphing calculator.